Alright, we're going to be talking about angle relationships today. This is Chapter 8, Lesson 3. A pretty easy warm-up today. Please make sure that you're copying down the entire sentence. It'll only take you a minute, so don't be whining about it. Press play when you're ready to correct. Alright, angles whose measures have a sum of 90 degrees are complementary. A part of a line that starts at one point and extends forever in one direction is called a ray. Angles whose measures have a sum of 180 degrees are supplementary. And a part of a line between 2 points is called a segment. Okay, no vocabulary today, so yay for that. Use the diagram to find each angle measure. So if measure of angle 1 is 37 degrees, what is the measure of angle 2? So angle 1 and angle 2 are supplementary angles. You know that adding them together is 180 degrees. So we could find the difference between 180 degrees and 37 degrees. And this will give us 134 degrees. So we know that angle 2 is 134 degrees. We also know that angle 2 and angle 3 are supplementary. If you add those two together, you'll get 180 degrees. So if angle 2 is 143 degrees, plus angle 3 should give us 180 degrees. This means that angle 3 is also 37 degrees. This is true for any two lines that cross like this. The angles that are across from each other, like 1 and 3 and 2 and 4, are always going to be congruent. So the measure of angle 1 is going to be equal to the measure of angle 3. The measure of angle 2 is going to be equal to the measure of angle 4. Okay, so both 1 and 3 will be 37 degrees, and both 2 and 4 will be 134 degrees. These are called vertical angles. And just to review, this little equal sign with a squiggly on top is read as is congruent to. Okay, so they have the same angle measure. Okay, so if angle 4 is y degrees, find measure of angle 2. Well, measure of angle 4 and 2 need to be congruent. They are vertical angles. That makes them congruent. Okay, so if you think back to the last example, the two angles that are right next to each other are supplementary. Two angles that are right next to each other are called adjacent angles. Adjacent angles are always supplementary when we're talking about two lines that cross like this. Vertical angles, angles across from each other, are always congruent. So we know that if the measure of angle 4 is y degrees, the measure of angle 2 will also be y degrees. Okay, so we don't need to do all of this work. We already figured this out in the last problem. Okay, if the measure of angle 1 is 42 degrees, we know that the measure of angle 3 is also 42 degrees. Because these two added together are supplementary angles, they'll be 180 degrees. Okay, which means that angle 1 is 42 degrees, angle 2 is 138 degrees. If angle 2 is 138 degrees, angle 3 must be 42 degrees. If angle 3 is 42 degrees, angle 4 must be 138 degrees. Okay, so these are the things I've just been talking about. The angles in example 1 are examples of adjacent angles and vertical angles. These angles have special relationships because of their positions. Sorry that the order of this lesson wasn't like normal. So you can go ahead and just start a vocabulary section of your notes now, and then we'll continue with the rest of the examples. So adjacent angles have a common vertex and a common side. Adjacent angles are right next to each other. So if you think about when we're sitting in class, the person that's sitting right next to you is your adjacent partner. Okay, you're sitting right next to each other. Vertical angles are the non-adjacent angles formed by two intersecting lines. So if you think about when you're sitting in your lab groups, the person that is diagonal across from you, it's not next to you, it's not right across from you, you're not facing the person, you're not right next to them, it's the person that's diagonal to you. That would be your vertical partner. Okay. A transversal is a line that intersects two or more lines that lie in the same plane. Transversals to parallel lines form angles with special properties. So the first special property is alternate interior angles, and those are the pink angles there, and then the blue angles. Alternate interior angles are congruent. So the two pink ones are congruent to each other, the two blue ones are congruent to each other. Alternate exterior, so the outside, alternate exterior angles are congruent to each other. Again, the pink ones and the blue ones. And then corresponding angles. This means they're in the same position on both of the different intersections. So the blue ones are in the same position. They're like the top left-ish position. The pink ones are the top right. Purple ones are the bottom right, and the green ones are the bottom left. Those are corresponding angles, and each of those color-coded are also congruent to each other. And this only works when the two lines they're intersecting are parallel. Okay, so if you copied down the information and the little pictures on the last slide, you don't really need this, but this is just put into words everything that was on that screen. If two parallel lines are intersected by a transversal, corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent. If the transversal is perpendicular to the parallel lines, all of the angles formed are 90-degree angles. Alright, in the figure, line L is parallel to line M. Find the measure of the angle. So we're finding the measure of angle 4. Okay, so corresponding angles are congruent, as I just said. So we're looking at the position it is in. So angle 1 matches up, it's in the same position, top right, as angle 5. Angle 3 and angle 7 are in the same position, they are corresponding. Angle 2 and angle 6 are in the same position, they are corresponding. And angle 4 and that 124-degree angle, those are corresponding, so they are congruent. So this means that angle 4 is 124 degrees. Okay, angle 2 shares a couple of things with, let's see, 124 degrees plus angle 2. These are supplementary angles, so adding them together will be 180 degrees. Or angle 1 and the 124-degree angle are supplementary, so we know the sum of those will be 180 degrees. So you'll find the difference between 180 and 124, and we find that angle 2 is 56 degrees. We also know if angle 2 is 56 degrees, so is angle 1, so is angle 6, and so is angle 5. If you know that top angle is 124 degrees, we know that angle 3 also is, and so is 4, and so is 7. So when you have two parallel lines cut by a transversal, you only have 2 different angle measures in the whole thing. All 8 angles will be one of 2 measures. Okay, so finding angle 6. Okay, this one is not congruent to 124 degrees. It's not corresponding. So again, we'll use supplementary angles, and we already know that if it's not 124 degrees in this figure, it's going to be 56 degrees. Okay, 56 and 124 give us that supplementary 180 degrees. Okay, so these two lines, line M and N, even though it says L and M, line M and N are parallel. So we're finding the measure of angle 7. So angle 7, angle 6, angle 3, and that 144 degree angle, those are all congruent. They are all either corresponding or alternate interior angles or alternate exterior angles. We know that angle 144 degrees is congruent to the vertical angle, which is angle 3, which is congruent to the alternate interior angle, which is angle 6, which is congruent to the vertical angle, which is angle 7. So we know that angle 7 is 144 degrees. Okay, angle 1 is supplementary with the 144 degree angle, so we can just find the difference there, and we get 36 degrees. This means that angle 1, 4, 5, and 8 are all 36 degrees. Angle 1 because of supplementary angles, angle 4 because of vertical angles, angle 5 because of alternate interior angles, and angle 8 because of vertical angles. Okay, angle 6, we know without doing any work, is 144 degrees because those are corresponding angles. They're both in the same position on their 2 lines. Alright, here is your lesson quiz. Go ahead and copy down, just sketch the picture there and answer these questions, and we will go over the solutions in class.